I've given you 5 laws in naming IUPAC compounds. Okay. One other law you should add again to it is if there are more than 2 or more than 1 functional group, if there are more than 1 functional group attached to any carbon atom, if there are more than 1 functional group attached, if there are more than 1 functional group attached to any of this carbon atom, okay, it would be named alphabetically. It will be named alphabetically. It will be named alphabetically. Okay, what am I trying to say? This example of what I'm trying to say, very, very instructive. Okay, what I want to say, what I'm trying to say is, if we have something like this, now this is a functional group. Like we have OH, we have OH, we have CH3, and we have F. You know what F is now?
Aye.
Sorry? Fluorine, right?
No.
Fluorine.
Yes, yes.
Fluorine. Okay. Now, this is what I mean. Though this is an advanced form, they may not teach you now. They may not teach you these parts that I'm telling you. But let's just do it in an advanced way. Now, what I'm trying to say is, if you have more than, now we have different functional group. Like this looks crazy. We have a different functional group. Different functional group. Look, I'm going to put this chlorine. Now, if we have about 1, 2, 3, 4 functional group. Now, when there are more than 1 functional group, this is what you do. Look at how we name them alphabetically. Consider this is F, fluorine, hydroxy, right? This is, remember, this is, we have okay, I'm coming. We have fluoro. What's Zoom I downloaded? It's giving issues. I'm coming. We have fluorine. We have hydroxy. We have methyl, right? And what's the last one we have? Chloro. Okay, chlorine. Now, which one comes first in alphabetical order? Which one comes first? Chloro. And chloro is at this other side. You see where chlorine is? This is where you start your numbering from. Because of chlorine comes first. So you start your numbering from here. 1, 2, 3, 4, 5. Okay. Now, let's name this together. Oh, yeah. Name this for me.
2, 4, 5.
Sorry, what did you call it? No, start from this now. Chlorine, start from chlorine. Okay.
2.
2,
2.
No. Okay, let me help you out with this. This is 2-chloro is going to be a very long compound. We are going to call all of them. 2-chloro, which after chlorine, what comes next? Fluorine, right?
Yes.
2-chloro, 5-fluoro. What comes next? H, right?
Yes.
2-hydroxyl hydro.
Oh.
Where is this methyl? 4-methyl. Okay. Now, what's it? We are done calling all of them. 1,6. Then we call that hexane. So this is how I was trying to explain that once you have something like this, you call it 2-chloro, 5-fluoro, 2-hydroxyl. You make sure you call them alphabetically. The alphabetical order must be followed because you have more than one. You have more than one. Um, more than one. What do you call it? Functional group. This also we could. This is how. So this is how we do this. This could also be an alkanol family because it's having the all. This can also be an alkanol family or alkanol family. Okay, but there's another way we can call this. There's another way we can call this. This can also be 2-chloro, 5-fluoro, 4-methyl. Then this hexane, this OH is in the second one. I'm going to call it hexan 2-ol because I told you this OH is an hexanol, it's alkanol family. That's another group entirely. So so this is it can also be like this, or it could be named like this. If you name it like this, you're correct. It could also be named like this, hexan 2-ol. Whenever we see OH attached to something, it's an hydroxyl group, and an hydroxyl group is also part of the alkanol family. All right. Okay, that looks. You see, that looks quite complicated. Awesome, but for your level, we're going to stick to what we've told you. So I wouldn't want to go further. So I just start again. All right. Now, let's come back to what we are meant to do. The next thing after this, it's coming. The next thing we will need to go on further is let's see. Okay, crude oil and natural gas. Crude oil and natural gas. Okay, now while talking about crude oil and natural gas, you understand that another name. You understand that another name for crude oil is petroleum, and crude oil, petroleum, which is called petroleum, is the chief source of all hydrocarbons. Crude oil is actually the chief source of hydrocarbon. Now, how do we know crude oil? How do we know a substance? This is crude oil. One of the things we should understand about crude oil is number one, it is dark, it is sticky. Most times it is sticky and it's a viscous liquid. When we say something is viscous, that means it doesn't flow easily. Like another example of viscous liquid is palm oil. if you bring palm oil and water together and you throw them in a plane, you will notice water will flow more compared to palm oil. What is the cause of that? That is viscosity. Viscosity. Now, it is believed that crude oil, now how do we get crude oil? Crude oil is formed by the gradual decomposition of the remains of marine plants and animals. Now, when they decay and they are being decomposed, they form sediments and rocks at the bottom of the sea. They form these things at the bottom of the sea. And so crude oil is actually a mixture of gaseous, liquid, and solid alkane. Remember, we're talking about alkanes. So crude oil is a mixture of gaseous, liquid, and solid alkanes, cycloalkanes, aromatic hydrocarbons. Crude oil is a mixture of gaseous, liquid, and solid alkanes, cycloalkanes, aromatic hydrocarbons. Now, what of natural gas? Natural gas most times is actually found together with crude oil and water in traps, or what we call them reservoirs, between the layers of the bottom of the sea. Now, how do they get this? Most times when they drill, the first thing that comes up is natural gas. The next thing that comes up is your crude oil. The next thing that comes out is your water. Why? Water is heavier. Water most times is more heavier. So natural gas consists mainly of methane. Methane is what we use, is our cooking gas. Now, methane, ethane, propane, these are cooking gas. Natural gas consists of those first four alkanes we talked about: methane, ethane, propane, butane. Now, we also know that natural gas is used as domestic, and we can also use it as industrial fuel. I need you to know this. Where was crude oil found in Nigeria? Where? It was found in a place called Oloibiri. Let's write that down. Crude oil was found in a place in Nigeria, called Oloibiri in the year 1956. And where is Oloibiri? Oloibiri is in Oloibiri is somewhere in Bayelsa State. Okay. Now, when we talk about refining of crude oil, what is refining of crude oil? Now, crude oil is actually crude oil consists of so many things, and now crude oil must be refined to make useful fuels and chemicals. Now, when we talk about refining of crude oil, this has to do with the separation or conversion of crude oil into other products. Now, when crude oil is taken from the oil refineries or oil fields to the refineries, the crude oil, when it's taken from the oil fields to the refineries, is processed in 3 stages. Number one, separation. Separation is done. Why? Because of some impurities. When they drill, there are some things they see, some impurities like sulfur, some impurities like, so we have some impurities of sulfur, we have some impurities of hydrogen sulfide, we have impurities of CO2 and every other thing. So the first part has to do with separation. The next thing has to do with conversion, converting of crude oil into various other products, natural gas, like petrol, our fuels, our kerosene, our bitumen, our asphalt, and every other things. And the next stage, number 3, is purification. Okay, now, how is crude oil separate? How can we refine crude oil? It's through a process called fractional distillation. Fractional distillation. Remember, I told you refining has to do
So
with
the same stage is well.
Sorry?
So the third stage.
The third stage is purification. Purification. Have you gotten that?
Yes.
Okay. Now, this is what we know of crude oil is that the petroleum products are actually the fractions obtained from the fractionating tower, and where the crude oil is actually being the petroleum products, like I said, the process is called fractional distillation. I mean, we use the fractionating column to refine the crude oil. Now, the question is, if crude oil is placed in a fractionating tower, how do their substance separate? How do they separate? How do they separate? Very important. How do they separate? Now, I must tell you something, is that their process, the petroleum products separate due to the differences in their boiling point. They use their boiling point to separate due to the differences in their boiling point. Now, the lower one comes up first, followed by the next one, followed by the next one. An example of the fractionating towards our column is something like this. An example is we have my drawing. The first product comes up. The next one comes up. Let's just take this an example. When the crude oil, the first product comes up here, that's the one with the lower boiling point, separates first, followed by the next one with this one will be higher than the one on top. The next one will be higher than the one on top. The next one will be higher than the one on top. So that means what we are trying to say is that most times natural gases comes out first because gas is lighter. Gas is lighter, so natural gas comes up first. They can easily diffuse into the air, so they're very light. Followed by liquid water. Those that are liquids, they start coming out. That's why you have your petrol. Your petrol is liquid. Petrol comes out. Your fuel, kerosene, they come out because they are liquids. The next thing again are the solids. The solids are asphalt, bitumen that are used for roads. Those are the last things that come out from the crude oil. I guess I have a video on that. Let's see. Okay, let's see what's it's all about. I guess you can see this, right?
Yes, sir.
Okay.
In today's video, we're going to take a look at crude oil and see how we can separate it into its different components using fractional distillation. Crude oil is a fossil fuel that we get from deep under the ground, and is basically a mixture of lots of different compounds. Nearly all of these compounds, though, are hydrocarbons, which contain only hydrogen and carbon. And the most common type of hydrocarbons are alkanes, which we covered in the last couple of videos. Now, crude oil is formed naturally from the remains of dead plants and animals, particularly plankton, that died millions of years ago and were buried in the mud. Then, in the millions of years between then and now, the high pressures and temperatures under the ground turned this organic biomass into crude oil. As it formed, this crude oil soaked into the rocks and was stored for millions of years. But we can get it back out by drilling into the rock and sucking it up to the surface. As crude oil takes so long to form, it's effectively a finite resource. And if we continue to extract and use it at the rate that we are now, then one day we'll run out of it completely. This is why we refer to fossil fuels like coal, oil, and gas as non-renewable fuels. Once we've extracted the crude oil from the ground, we need some way to separate out all of the different hydrocarbons in the mixture, because they each have different properties, and so we'll use them for different things. To do this separating, we use a process called fractional distillation, which involves heating the crude oil up and separating out different compounds by making use of the fact that the different compounds all have different boiling points. The first step is to feed the oil into a chamber and heat it until most of it has turned into a gas. We then pass this gaseous mixture into a fractionating column, which is really hot at the bottom, but gets cooler towards the top. The idea is that these hot gases will then start to rise up the column. But importantly, as soon as they reach a region that has a lower temperature than their boiling point, they'll condense into a liquid. The hydrocarbons with the longest chains, so the most carbons, have the highest boiling points, and so they'll quickly condense back into a liquid and drain out of the column early on, because it's not hot enough to keep them in their gaseous states. These are things like bitumen, which we use to surface our roads, and heavy fuel oil, which can be separated further and used for things like heating oil, fuel oil, or lubricating oil. The shorter chain hydrocarbons, though, have much lower boiling points, so they'll stay as a gas for much longer as they rise up the column until they finally reach a cool enough temperature that they condense into a liquid. This gives us fuels like diesel and petrol, which we use in cars and other road vehicles, and kerosene, which is used in jet engines. Some hydrocarbons, though, are so short and have such low boiling points that they stay as a gas the entire time. For example, LPG, which stands for liquefied petroleum gas, contains mainly propane and butane, which are both very short chain alkanes. If we compare these different groups or fractions, the ones towards the top, which are the shorter chains, are the most flammable, and so they tend to make the best fuels. Meanwhile, the longer chain hydrocarbons, here at the bottom, are often poor fuels, so are instead either used for something else, or can be broken down into smaller hydrocarbons in a process called cracking, which we'll take a look at in the next video. The last thing to point out is that as well as all of these fairly direct uses that we mentioned here, petrochemicals, which is what we call all of these substances that we get from crude oil, can also be used as feedstock, which just means raw materials for the petrochemical industry. You use them to make things like solvents, lubricants, polymers, and detergents. Anyway, that's all for this video, so hope you found it useful. If you did,
okay. That was what I was trying to explain on crude oil, the fractionating. Okay, now the next thing we can continue on. It's now let's look at. I don't know. I want you to divide your table. I don't know if you have this table I have now. Number one, I wanted to show you I want to tell you about, we have the fractions, we have the boiling point and the uses. The first thing that comes up, okay, one of the first thing that comes up that's the lower temperature. We have the first thing that comes up is a petroleum gas. The petroleum gas, okay, the petroleum gas, now that which is also called the natural gas, the carbon atoms it has from C1 to C4. Remember, C1 to C4, that's from methane to butane. So from C1 to C4. Okay, make a tabular form, please. Write fraction, write the serial number, fraction, number of carbon atoms, boiling point, and uses. Okay, are you done?
Yes, sir.
Okay, number one, I said number one is petroleum gas. The number of carbon atom is C1 to C4. The boiling point is below 40 degrees Celsius. And the uses is is used for fuel and manufacture of other organic compound. Okay. Number two, we have petrol or gasoline. Number of carbon atom is C5 to C10. Boiling point is 40 to 200 degrees Celsius. And it is used as fuel in motor cars and generator. Okay, the next one is Carousino Paraffin Oil. Number of carbon atom is C11 to C15. C11 to C15. Boiling point is 200 to 250 degrees Celsius. Now, what do we use kerosene for? We use kerosene as fuel, as aviation fuel. Aviation fuel, that's in your jets, in an airplane. Surprisingly, they use kerosene as the fuel, used as aviation fuel in aircraft. and also as fuel for lantern. Okay, number 4. We have diesel or light gas oil. The number of carbon atom is C16 to C20. Boiling point is 250 degrees to 350 degrees Celsius. And we use it as fuels in engines or buses. We use it as fuel in engines or buses. We also use it in boats and tractors. Okay, have you gotten that?
Yes, sir.
Okay, the next one is lubricating oil. Now, lubricating oil C20 to C30. We have 350 to 500 degrees Celsius. We use it in candle making. Candle making, we use it for making cream. We use it for making hair care products. Okay, the next one, the last one is bitumen or asphalt. Now this one is greater than C30, that's C30 and above. Carbon atom C30 and above, Boiling point is above 500 degrees Celsius. And is used for road surfacing. For road surfacing. All right. So if you notice what we just did now, I want you to notice something. The first one was gas, right?
Yes, sir.
From the second one to the fifth one. From the second one to the fourth one and fifth one, you notice they are liquids, but the liquids start getting thicker.
Yes.
Okay, now the last one becomes solid. All right, so that's exactly what I was trying to explain there. Now let's come to let's see, okay, we're done with that. Cracking. We'll just go through cracking and cracking, reforming. Okay, what do you understand by cracking?
Cracking is like the heating of
What
the
did you call it?
heavy product. Heating.
You said?
Heating.
So I didn't get that word.
Heating. Like
Heating, okay.
heat. The heating of the heavier, like the bottom, the heavier hydrocarbon.
Okay.
The product, the bottom product of crude oil, like the splitting it to more lighter hydrocarbons.
Okay. Now, what cracking is all about is because the quality of petrol obtained by fractional distillation of crude oil is about 20% of volume, is about 20%. So, cracking therefore can be used to provide more petrol since there's high demand, since the demand is high, and it can be used as a source of alkenes. That's why we use cracking. Now, what is cracking? Cracking is a process whereby large molecules, heavy oils, are broken into smaller molecules. Heavy oils, the process whereby heavy oils or large molecules of hydrocarbon are broken into smaller molecules at high temperature, pressure, and the presence of a catalyst. Did you get that?
So they're broken into.
Okay, this is right. Let me give you in a formal way now. This is a process whereby large molecules of heavy hydrocarbons This is a process whereby large molecules of heavy hydrocarbons are broken into smaller molecules, at high temperature, pressure, and in the presence of a catalyst. Have you written that?
Yes, sir.
Okay. Now, I want you to write this as a note that usually, okay, just write this. Petroleum fractions with more than 11 carbon atoms can be cracked. Have you written that?
Yes, sir.
Okay. Now, okay. Also write this note again. During cracking, ethene, that's ethene, ethene, ethene is produced. Ethene is produced, and it is the major raw material in the petrochemical industry. And it is the major raw material in the petrochemical industry. Have you written that?
Yes, sir.
Okay, okay. Now, there are two types of cracking. Let's look at two main cracking process. Number one, we have thermal cracking, and we have the catalytic cracking. Now, when we talk about thermal cracking, please write, this involves heating heavy oils. This involves heating heavy oils, such as the heavy oils are lubricating oil, diesel oil, and kerosene. This involves heating heavy oils. So you can write in brackets your lubricating oil, the diesel oil, these are also heavy oils. We also have kerosene as heavy oil to about 600 degrees Celsius under pressure. Now, right, this leads to the decomposition and formation of a mixture. This leads to the decomposition and formation of a mixture of more volatile alkanes, alkenes and hydrogen. Okay, I'm going to use this to explain. Something. Let me share. I hope you're still there. Are you there? So this is how cracking is, that if you are being given, you should know how to, if you are being given this, you should know the next one you'll be getting. So we are getting an alkane and an alkene. So this is an alkene, because if you see 3 plus 3 is 6, that means they have CnH2n. Okay, now, because you should also understand the reason for cracking. The reason for cracking is to get probably more fuel. If fuels are becoming expensive, so we can actually get the heavy hydrocarbons, the heavy oils, the heavy ones, heat them under extreme temperature and pressure, so they can give us the lesser compounds, the lesser ones. All right, now coming, okay, now please write, the mixture is separated by fractional distillation. The mixture is separated by fractional distillation. Now this is actually what we just did now. That C11 is kerosene, giving you C8. C8 is petrol, and the other one, C3, is propane. C8 is octane, so which is also called petrol. C11 is kerosene. Okay, now number 2, let's talk about catalytic cracking. Catalytic cracking. Catalytic cracking, okay? Now, catalytic cracking, now if we define the thermal cracking by the heating of heavy oil to temperature, catalytic cracking has to do with the heating of, in catalytic cracking, okay, please write this. In catalytic cracking, the heavy oil is heated to about 500 degrees Celsius. Is heated to about 500 degrees Celsius under reduced pressure and in the presence of a natural clay. Under reduced pressure and in the presence of a natural clay. in bracket, a mixture of silicon 4 oxide and aluminum oxide. And aluminum oxide as the catalyst. Have you gotten that?
Yes.
Okay, please note. The product of cracking depends on the starting material. The product of cracking depends on the starting material and the reaction conditions. And the reaction conditions such as temperature, pressure, and the nature of catalyst used.
So temperature, pressure, and
The nature of catalyst used. Okay. The next thing again we should note down is in hydrocracking, Hello? Hello? This is something very instructive that in hydrocracking, hydrogen is passed during the reaction mixture. And guess what? Um, guess what? Oh God, do I still have that? Okay, good. When hydrogen is passed into this reaction mixture, if hydrogen is passed into this reaction, guess what will happen? This alkane will be converted into alkane, because when hydrogen is passed into it, the hydrogen reacts with this to give C3H8. So in hydrocracking, so we'll be having more of alkanes, no more alkanes. We'll be having more of alkanes and again, and we won't be having any more of alkene. All right, that's in hydrocracking. Now, let's see. Let's go to reforming. Let's say something about reforming. Hello? Okay, it's still there.
Yes.
Okay, in reforming, the molecules do not crack. Please write this. In reforming, the molecules do not crack, but are reformed or reshaped. In reforming, the molecules do not crack, but they are reformed or reshaped. Now, in reforming, what really happened is the straight chain alkane, the straight chain alkanes are converted using catalysts into branch chain isomers. In reforming, straight chain alkanes are converted into branch chain isomers. Now, branch chain isomers like the cycloalkanes, like the benzene. So the straight chain are converted into branch chain. Now, the question now is, why reforming? Why do we have to engage in reforming? Why would we have straight chain being converted into branch chain? Now, what's the purpose? The purpose of reforming is to convert the low-grade petrol to high grade. The purpose of this is to convert the low grade petrol. That means we want to improve the quality of our petrol. We want to improve the quality want to improve the quality of our petrol. Now, reforming techniques. The techniques used in reforming, number one is isomerization. Isomerization. We're going to talk about isomers later on. Isomerization. Number two is cyclization. That's CYCLIZATION. And the last one is aromatization. Have you gotten that?
Yes, sir.
Okay. Now, what's now the difference between cracking and reforming? What's the difference between cracking and reforming? Now, number one, I think I'm just going to, please, I'm just going to stop here. Okay, let's continue. Let's continue. I still want to rush, see if I can rush to church. Okay, now, the difference between cracking and reforming, number one, cracking involves breaking large molecules of petrol. Cracking involves breaking large molecules of petrol fractions into smaller molecules. Cracking involves breaking large molecules of petrol into smaller molecules, while reforming involves rearrangement of atoms in the molecules. While reforming involves rearrangement of atoms in the molecules of petroleum fractions. Rearranging, that means we are trying to make, if you notice the last time I taught you about these structural formulas of alkanes, structural formulas, there was a time I gave you one, you didn't know that it was something we had done before. It was because I rearranged it. So the rearrangement of atoms in molecules of petroleum fractions to obtain either a branch one or a cyclic one is called reforming. So reforming involves rearrangement of atoms in the molecules of petroleum fractions. Reforming involves rearrangement of atoms in the molecules of petroleum fraction to obtain branched and cyclic hydrocarbon. Okay, I think I'm going to stop at that point. So I'll give you the others as assignment to get me other differences between, that'll be your first assignment. State 5 differences between cracking and reforming. Cracking and reforming. Okay. Have you gotten that? You've got your assignment?
Yes, sir.
Okay. Now the next thing, please take this assignment also. Explain octane number. Explain the octane number. Number 3, it's mention 2 ways of improving the octane number of petrol. Mention 2 ways of improving the octane number of petrol. think we're almost done with what you are even meant to do. Let me see. This is almost the last part of what you're doing. Okay. Then we'll go proper later on into alkenes and alkenes. Have you written them, please?
Yes, sir.
Okay. I'm sorry. I hope you will pardon me for today. I want to say I can rush back to church before it ends.
Okay.
Tomorrow we'll be meeting again for physics. I think we should continue with. I think what I'll do is your school now they've ended third term work for you, I guess, as much for chemistry, right?
Mm.
I think this is the last note for you guys.
Mm.
Check. Is it? Did they give you the course outline? Scheme of work, sorry.
Yes.
Is, hydrocarbons, is that the last thing to be discussed?
No.
What's the next thing after
Yeah. Industrial and applied chemistry.
What's under industrial and applied chemistry? What are you talking about?
Raw materials, sources of raw materials.
Okay, raw
uses.
materials.
We also have heavy and fine chemicals.
Yes, heavy and fine chemical.
And types of chemical industry.
Okay, after then, what next again, please?
That's it.
That's the end. Okay,
After types of chemical industry.
after then too.
After types of chemical industry.
Okay, heavy and fine chemicals, they're under that. Okay, what about for physics? After